Today's lesson is on derivative of inverse trigonometric functions. We're going to start the lesson with deriving one of the derivative of inverse trigonometric functions, looking at the process how they derived the derivatives. This will help us to understand how they came up with an equation of the derivatives, and hopefully it'll be less thing to remember in the future. So let's say we have y equal to inverse of sine of x. First, since we don't know how to take the derivative of an inverse function, so we're going to rewrite into the equation that we know how to take the derivative of. Using the properties of an inverse trigonometric function, we could rewrite this as sine of y is equal to sine of inverse of sine of x. And we could state that sine of y is equal to just x. Again, sine and inverse of sine will cancel each other out. Now we have an equation where we know how to take the derivative of. So we could say that derivative of sine of y is cosine of y times dy dx. On the other side of the equation, your derivative of x is 1. Again, notice that we took the derivative implicitly, and our goal is to solve for dy over dx, which is known as the derivative. So we're going to divide cosine of y to the other side of the equation. Our last step will be we need to rewrite this cosine of y into a function of x, since we started off with x. Since we don't know what cosine of y is, we're going to look at this equation to help us to figure out what cosine of y is. Notice that in this case, y is your angle, and we know that trigonometric function is a right triangle, and comparing the ratios of the sides. So let's say we have a triangle. In fact, so let's say we have a right triangle. In this right triangle, we're going to call this angle y. Sine is the proportion of opposite over hypotenuse. So opposite side of angle y will have an x. The hypotenuse will have 1. Since this is a right triangle, we could use Pythagorean theorem to figure out this will equal to, more like this adjacent side will equal to 1 minus x squared. So now, since we have an angle y, we could figure out what cosine of angle y is. So our derivative is equal to 1 over, cosine is adjacent over hypotenuse, so we have radical 1 minus x squared. And here is the derivative of an inverse. And that's how they derive the derivative of an inverse trigonometry function. Now they all have the same behavior. So all 6 inverse trigonometry function has the same idea behind it. We're going to try to rewrite them into trigonometry functions since we know how to take the derivative of. And then using the right triangle, we're going to replace it back after taking the derivative implicitly. So I would suggest you guys to try it on your own for the other 5 remaining inverse trigonometry functions. So let's see how they look like. U is a differentiable function of x, so I'm going to explain it in terms of chain rule, where x is not a single variable, it could be a function. We have arcsine of u, which is equal to derivative of u over 1 minus u squared. Again, it's very similar to what we had. We have 1 over radical 1 minus x squared. We have 1 there because derivative of x was 1. And again, with a similar concept, you should be able to solve for derivative of inverse of cosine, derivative of inverse tangent, derivative of inverse cotangent, derivative of inverse secant, and finally derivative of inverse cosecant. One thing to highlight is these three functions. Notice that they're exactly the same function, only difference is they have a negative. Just like the regular trigonometric function that starts with a C will have the negative in front of it. Okay, so let's look at a couple of examples now. Example 1. Find the derivative y equal to arctangent of x to the second power. So in this case it would be a chain rule because your u in this case would be arctangent of x. Therefore we could rewrite this equation as y equal to u to the second power. So derivative of y equal to u squared is y prime is equal to 2 times u times du. And we know what u is. Our derivative of u, which is the arctangent, is 1 over 1 plus x squared. So our derivative of y will equal to 2 times the arctangent of x times our derivative of u, which was 1 over 1 plus x squared. So our derivative is 2 arctangent of x over 1 plus x squared will be our answer. Find the derivative of y equal to arc cosecant of e to the 3x plus 1 power minus x. In our case, we have two chain rule. We will say u is equal to e to the 3x plus 1. So our derivative is 3 times e to the 3x plus 1. You can keep in mind this is a chain rule. So now we have our equation as y equal to arc cosecant of u minus x. So the derivative of y is equal to negative du over absolute value of u times square root of u squared minus 1. That was the derivative of arc cosecant of u minus 1. Now let's substitute our u and du and we will have our answer. So y prime is equal to negative 3 times e to the 3x plus 1 power over absolute value of e to the 3x plus 1 power times square root of e to the 3x plus 1 to the second power minus 1 and subtracting the entire fraction. And here is our derivative. Keep in mind you need to have an absolute value there. There are cases where this function could never be negative, so you don't have to put the absolute value. But my suggestion is keep the absolute value so you don't make a mistake. Example 3. Find the derivative of arc cosine plus x times radical 1 minus x squared. So y prime, again, looking back to the derivative equation, arc cosine of x is negative 1 over radical 1 minus x squared. For the second part, we will need product rule. So this is f, second part is g. So if you take the derivative of x times radical 1 minus x squared, you should get radical 1 minus x squared plus 1/2 of 1 minus x squared to negative 1/2 times negative 2x times x. So now let's simplify this. Y prime is equal to negative 1 over square root of 1 minus x squared. This will be radical 1 minus x squared minus x squared over radical 1 minus x squared. These two terms can be combined. So if you combine those two fractions, you should have y prime is equal to negative 1 minus x squared over radical 1 minus x squared plus radical 1 minus x squared.